Hello, good afternoon. I'm Gustavo Pichardo, a master's student in engineering sciences at the Technological Institute of Toluca. The topic is polypyrrole carbon nanotubes composite for its application as a catalytic support in a proton exchange membrane fuel cell, PEM. Some materials used as a catalytic support are a crucial component in this type of fuel cell due to their influence of the catalysis durability and chemical reactions. Usually, catalytic support are made from carbon-based materials. However, these materials present problems in the operation of the fuel cell, such as corrosion or oxidation, leading to the reduced cell performance. Therefore, in this case, we use a polypyrrole carbon nanotubes composite. It was synthesized by electrochemical polymerization using sodium sulfate as an oxidant and sodium dodecyl sulfate as a dopant. In the methodology, we use distillate pyrrole, oxidant, dopant, carbon nanotubes, and distillate water for preparing a solution, which is taken to a sonicator for its homogeneity. Then, using the electrochemical reactor, the solution is deposited, applying a voltage of 5 volts with an amperage of 0.04 ampere for 20 minutes. The resulting film is weighed, dried, and characterized. We obtained different films such as polypyrrole with SDS and with 175 milligrams of carbon nanotubes. Other is polypyrrole with SDS and other is only polypyrrole. Their morphological, structural, thermal, and electrical properties were characterized using scanning electron microscopy, Fourier transformed infrared spectroscopy, thermogravimetric analysis, and two probe methods respectively. How results in the same, the polypyrrole is observed with the characteristic cauliflower shape, while those containing carbon nanotubes are observed as the polypyrrole grows on them, and protruding elongated forms are observed. In the FTIR, various bands appear. In 3712.6, there is the nitrogen-hydrogen bond of stretching vibration of the polypyrrole. In 2910, there is the alkyl of the SDS. In 2171, there is the carbon-hydrogen bond. In 1682, there is the carbon-carbon double bond of stretching vibration of the polypyrrole. In 1509, there is the carbon-carbon bond of stretching vibration of the pyrrole ring. In 1457, there is the carbon-nitrogen bond. In 1112, there is the double bond sulfur-oxygen of stretching vibration of the sulfonate anion. And finally, in 1005, there is the carbon-hydrogen deformation bond. In the analysis of TGA, reveals that the polypyrrole SDS and 100 of milligrams of carbon nanotubes, and polypyrrole films lose the most weight during the test. After 200 degrees Celsius, polypyrrole with SDS and with 175 milligrams of carbon nanotubes and polypyrrole with SDS become more stable. Beyond 200 degrees Celsius and up to 550 degrees Celsius, polypyrrole is more stable. And finally, after 550 degrees Celsius, polypyrrole with SDS and with 75 milligrams of carbon nanotubes and polypyrrole with SDS films are even more stable, maintaining higher weight percentages. Finally, in the conductivity analysis shows that a polypyrrole film has higher resistance, resulting in lower conductivity. A polypyrrole with SDS and with 75 milligrams of carbon nanotubes film exhibits better conductivity compared to the others, with a value of 1.231 times 10 at last 1. How conclusions? Based on the obtained results, it can be observed that the polypyrrole with SDS and with 75 milligrams of carbon nanotubes, film exhibit the best thermal and conductivity performance. The morphological and structural analysis reveals the dopant failed with the presence of the carbon nanotubes owing to the operating condition of the cell. These films holds the potential to be utilized as a catalytic support. These are some sources I consult, and that's all. Thank you very much.